The built-in Servo library is good and very simple to use. However, there's more we can do with the hardware than it allows us to do. For example, how fast should a motor move from one position to the next? What about the ability to define a set of movements for the motor to perform and then send them with a single instruction? To achieve functionality like that, we need to use an external library. I'm going to show you how to use the var speed servo library written by Corman and updated by Philip van Allen. Thank you both for your work and contribution. The built-in servo library is pretty nice. It gives us the basic functionality to allow us to control servo motors, but we could be doing much more. So for that reason, I'm going to show you how to use an external library, which is this one here, var speed servo. You can access it at this location on GitHub, and it contains some instructions for usage and sample code. One nice thing about this particular library is that it allows us to, of course, use the right function as we did in the built-in library. Give it an integer representing the numbers of degrees that you'd like the servo to turn. But you can also provide the speed, so how fast would you like the shaft to move? When the built-in library, you can't do that, so the servo will just move as fast as it can. And another nice thing is you can also say to Arduino whether you'd like it to wait until the motor finishes moving before moving to the next line in the sketch, or to just forget about the servo, let it finish its movement on its own and move on to the next line. So in this case, we say true. We're going to wait, or the Arduino is going to wait until the servo confirms that it has completed the movement as instructed before continuing with the next line in the sketch. If we say false here, then the Arduino is not going to wait. It's just going to move on to the next instruction in its sketch and leave the servo complete its movement on its own. And there's other instructions and a lot of very useful functions that you can use here. So before we can use this library, we have to install it, make it available to our IDE sketches. To do that, you can download the zip like this. It's an archive, a zip archive. Download it. Once you have it, you need to change the file name or the folder name to make sure that it matches the name of the library. So this is the name of the library here, var speed servo. You need to make sure that this folder name matches the name of the library. So I'm going to remove the last few characters like that. Then I need to put this in a particular place on my file system, a folder that the Arduino keeps its libraries. So to find out what that location is, you open up the preferences of your IDE and you look at what it says. Now, this is where I keep my Arduino files and when and where the Arduino is going to look for libraries. So I'm going to use this information to copy the new library to. So I'm going to go to my Arduino library. Inside here, there is a folder called libraries. So I'll open it up. And in here, I'm going to copy a new folder that contains this library and paste it in here. I'm not going to finish this because I've already got a copy of this library. It's already installed. It's exactly the same thing. So once I finish with this, I have to restart the IDE. So quit the Arduino IDE and then start it up again. And once it's up, you can confirm that the new library has been imported and is available to use by having a look at the available library. So you go to Sketch, click on Import Library, and you can see that down here, the library we just used is showing up. So let's have a go at it. First, I'm going to ignore the part of my circuit that contains the potentiometer, and I'm going to load up the example called sweep, which is the matching example of the built-in sweep sketch. Let's run it. Okay. And this looks very similar to the sweep we saw earlier. It's a little difference here. Let's have a look at the sketch. So in the sketch, we start by including the var_speed servo library instead of the built-in servo library. Then we declare the myServo object. Just like we did earlier, we have a servo pin to be pin 9, and then we attach the servo at pin 9 to the myServo object. The write function is a little bit different to what we saw in the built-in servo library write function, because now we initialize the servo to start at degrees 0 and basically to go straight all the way to the beginning of its range of movements at maximum speed. So 255 represents the maximum speed that the attached servo can rotate. And we're saying true, which tells the Arduino that it should wait for the servo to reach that position 0 before it moves on to the next thing it's got to do, basically before it moves on to the loop function. So as soon as the servo finishes its movement back to position 0, we get into the loop function. In the loop function, we do 2 servo writes constantly. Notice that there's no loop here. So first we say to the servo mechanism, go to position 180, so that represents 180 degrees, as fast as you can, and wait until the servo reaches that position. Once it does reach position 180, then move on to the next instruction, where we write position 0, so we want to send the servo back to position 0 at a much lower speed, so at 30, and wait until that finishes. So it's a very powerful library. You can control several more aspects of the operation of a servo than you can do with the built-in library. Show you one more thing. Let's have a look at how to use the knob now using the var_servo library. So I'm going to bring up the knob example. Upload it. Connect. Okay. And upload. Alright, so there you go, same effect as before. I can move the knob and the servo moves accordingly. Having a look at the sketch, we start up the exact same way as in the last example. Do the same kind of we'll use the same way to attach the pin. Then we go and read the value at analog pin 0. We do the same mapping as the knob example when we use the built-in library. And now look at this. This is the exact same write function that we used with just one single argument as back in the knob example with the built-in library. So what this means is that the var_speed servo library allows us to use the write function in a variety of ways. One of which is just to provide the final position where we'd like the servo mechanism to move at, which is what happens with the original built-in version of this function. So if you have any sketches that were based on the built-in servo library, those are going to work just fine with the var speed servo library. You can always explore what else this library can do by looking at the documentation. Okay, so you can see here, for example, there are 3 different ways by which we can write instructions to the servo. A single parameter, you can have 2 parameters, final position and speed, or 3 parameters which have the final position, the speed, and whether Arduino should wait for completion or not. Okay, working with servo motors is real fun and very useful. So how about you extend your knowledge through an exercise? Can you build a circuit that contains a servo motor and 3 buttons? When you press the first button, the motor moves to 60 degrees. When you press the second button, it moves to 90 degrees. And when you press button 3, it moves to 180 degrees.